Okay, so we're in collections and we're in sets inside of collections. Sets are one of the four collection types, and we're going to look at the copy method this time. So I'm going to first of all just create a set, one that we've done before, and I will rename it to, just to be a bit more, we'll call it fruits. So fruits, and we can print out our set down below. We've got orange, apple and banana, and we can also add onto that an F string with the ID. So the ID of fruits, which is to get the memory, the place in memory location. So just remember that this ID method here, if I can hover over the ID method, it returns the identity of the object. So it's where it uniquely exists in memory. So again, if we run that, we now see that fruits has been assigned this number which represents its position in the memory. And the first thing that we're going to do is we're going to try and create a copy using the copy method. So let's create a copy, and we're going to be using the copy method. So when we do fruits.copy, so that's the first thing we'll do, is fruits.copy, copy, this one here, we see already that it returns a shallow copy of a set, which is something that we've seen before, certainly for lists, this shallow copy concept. And also, again, when we hover over copy, we see that it returns us something back. So we're getting something back, so we can assign that to a new variable, and we will call it copy underscore fruits. So that is a copy of our fruits, and we can do the same thing, which is, at least let's just do this. We can print our fruits, our copy of fruits, just like that. And we see down below we get exactly the same thing because it is a copy. And we can also do we'll do the F string again. We'll build it from the beginning, F string, and it is inside the curly braces, ID of, but this time it's going to be copy of fruits, and put the equals to just so that it looks like it's in the same format. And we see that when we create a copy, this shallow copy, that we get a different number. And if we remember back from previous sections, this different number means that it's a copy and it's in a different part of the memory. So it's almost like it's copied it from section 1 of the memory to section 2 of the memory. And the next part is we're going to, so we've done that, and we understand what copy is, and we're going to now we're going to create, so let's create a copy, but this time we're going to do it using variable assignment, which is basically a posh way of saying do it using the equals sign. So let's just call this assign fruits, and we will, this is the variable assignment, it's just equals to fruits. And we can again go along and print assign fruits, and if we run it, we see that we get exactly the same thing. So far everything looks the same. We've got apple, orange and banana 3 times, creating our copies. Now we go along and we print we'll do it again with the F string, ID, inside the curly braces, ID of the assign fruits equals to. And this is the memory location of where assign fruits will actually live. So let's have a look and see what happens there. Run the code, and we see that fruits ends in 8544, and assign fruits also ends in 8544, and in fact the entire number is the same. So it looks like these two here live in the same memory location, and this one doesn't. Now at this point still you might be thinking, Well, that doesn't really make a difference because we've got apple, orange, banana. We've got sorry, orange, apple, banana. We've got orange, apple, banana here, and we've got orange, apple, banana a third time over here. So, like, you know, what's the big deal? So, and this is kind of like where we highlight the difference. So let's just do a print, a few underscores. So that's the end of that little section. We've done everything, and it all looks good. So the next thing to do is now let's add some fruits. So now, oops, let's put a. Now let's add a fruit to fruits. Right, so we're adding a fruit to this fruits set. So let's just do that. We will go in here and do fruits. And remember that we can use the add method, so that's quite nice. And then we will add a fruit, and let's just stick in a lemon to start with. So we're expecting our fruits to be one larger because we've added lemon. So it's now going to be apple, orange, banana, and then lemon. Next of all, we will add some. So now let's add a fruit to, and we will add it to the copy of fruits. So copy underscore fruits. We're going to add it to our second set. So we do copy underscore fruits dot add, and we will add a different fruit. So let's just use a plum. And then finally, now let's add a fruit to assign underscore fruits, just like that. And we can do assign underscore fruits is also not equal to dot add. So we're doing the add method for a third time, and we'll add a new fruit. We'll call it a guava because I can't think of better fruit at this point. And we've now incremented each one of these lists, which are down here. So each of these sets, three by one item each. We've added a lemon to the top one, we've added a plum to the next one, and we've added a guava to the third one. So we should be able to, after doing that, print and then fruits, just to see what we've got, and fruits, and we can escape at that, print. Need to put the comma here and the colon here, sorry. And then we can again go and print, okay, copy of fruits, right, because that was our copy method. And we can do copy fruits. And finally, we can print with our assign method, fruits. And we put over here assign fruits. So these are our three sets that come back. Everything in the set, everything in each of these sets is unique, so everything will be added. There's no duplications. If we try to put a banana into a set that already existed in the set, we wouldn't be allowed, because we're only allowed one occurrence of each item in the set. That's the property, one of the properties of sets. So here we don't have any collisions. We've put new fruits into the sets. So we're expecting to get back orange, apple, banana, and lemon, orange, apple, banana, and plum, and orange, apple, banana, and guava. But when we run this, we see that we get this back. And what happens is we've got, where we've put a lemon into fruits, the lemon has also gone down into assign fruits. And where we've put a guava into assign fruits, the guava has gone into fruits. So the fruits list and the assign fruits list have both incremented by 2. And here's the increment, lemon and guava, lemon and guava. Whereas in the meantime, the copy fruits has only incremented by 1, which is the plum. And this basically quite nicely highlights the positioning in memory and what is happening in terms of a copy as opposed to an assignment. Both are in theory creating copies, but one is pointing to at least the assignment is pointing to the original memory address. So changes in either first the first variable here, the first variable here, or the assigned variable, either of these changes affects the original list that was there, or the original set in our case that was there, whereas the copy created a shallow copy. It's in a new memory space. We see that it's in a new memory space because it's assigned a different memory ID, and it therefore is unique, so it doesn't collide. Now, sometimes we like this collision, it's a useful property, and other times we don't like it. So it's more a case of that we have to understand how sets work, and also, by the way, this refers really to all of the other collection types. So how our collection types work and what this copy method actually does, which is it is creating a shallow copy of a set. So that's it. That's all done for the copy method in sets, in collections, in Python.